Hello, in this video we will learn about real numbers and the number line. So let's first talk about the real number line. So this is a real number line. We have 0 in the middle and positive numbers on the right side. 1, 2, 3, 4, and this real number line goes on all the way up to infinite. And similarly on the left hand side of 0 we have negative numbers, -1, -2, -3, -4, and these numbers go all the way up to negative infinity. And there are also decimal numbers in between, so 1.5 minus 2.5 minus 1.1. There are all the decimal numbers as well on in between, and this is called a real number line. Okay, so now we have some names, for the numbers on a real number line. Let's try explore those. For example, natural numbers. If you just talk about the numbers like 1, 2, 3, 4 without any decimal and starting from 1, 2, 3, all positive numbers, no decimal, those are called natural numbers. And we have whole numbers. Whole numbers are all the natural numbers, but we include one extra 0. These are called whole numbers. Similarly, we have integers. Integers are all the numbers without any decimals, but it contains positive. So see the positive 1, 2, 3, 4, 0, 0, and the negative 1, 2, 3, 4. All the negative numbers without decimals, 0, and all the positive numbers. And we divide integers into, we call these negative numbers as negative integers, positive integers, and 0. Okay, so integers involves positive integers, negative integers, and zeros. So we have prime numbers. Prime numbers are always greater than 1, and the numbers which are only divisible by itself. So for example, 2, 3, 5, 7, 11, and the next prime number is 13. It is only divisible by 1 and itself. And then the next one is 17, and you can write down all the prime numbers. And composite numbers are the numbers, these are the whole numbers greater than 1 which are not the prime numbers. That means numbers which we can write as a product of two smaller numbers. For example, 4. 4 can be written as 2 times 2. 12, 3 times 4. So these are called the composite numbers which can be written as a product of two smaller numbers. Next we have rational and irrational numbers. Let me first talk about decimals. Decimal numbers. So we all know that decimal numbers are something, they can be categorized into repeating decimals, so what are the repeating decimal numbers? So something like 3.66666, 2.5656, 2.391391, 2.563222. All these are repeating decimal. If we see that in the very first ones, after the decimal, 6 is repeating itself, right? We can write this as 3.6, and we can put a line on 6 just to tell the reader that 6 is repeating infinitely many times after decimal. In this second one, two-digit number 5656 is repeating, and we will write this as 2.56, and we put a line that will cover both 5 and 6 because 56 is repeating itself. In the third one, the three-digit number 391 is repeating itself, so we will put a line on all the way from 3 to 1 just to tell that all these three-digit numbers are repeating itself. In the last one, 563 is as it is. After that, this 2 is repeating itself, so we will write this decimal number as 5632, and we will put a line just on 2 because only 2 is repeating itself. All these decimal numbers are repeating decimal numbers. Let me talk about the terminating decimal numbers. So terminating decimal, terminating also means ending decimal numbers. So for example, if you know 1 over 2, if we have to write this fraction into a decimal, you will write 0.5. So after that there is nothing, after 5 there is nothing. So decimal, after certain decimal numbers, so this decimal number ends after certain decimal places. 1 over 4, it is 0.25, right? After 2 decimal places this number finished. So these are called ending decimal, when after certain places after decimal the number just ends. Okay, so there are non-repeating non-decimals. So the third type of decimal numbers are non-repeating and non-terminating. So what are non-repeating and non-terminating decimal numbers? Pause the video here and think about something. Okay, did you think about pi? So please look at your calculator. So please evaluate the decimal value of pi on your calculator. If you see, it is 3.141592, and this is a never ending, and you see that no pattern is repeating itself after the decimal. So this is a non-repeating, non-terminating decimal number. Now what else? Everyone, please look at the decimal value of square root of 2. So what you get? It is 1.41421356, and you see that this number is never ending and there is no pattern after the decimal which is repeating itself. It's a never ending, never repeating decimal number. So these are non-repeating and non-terminating decimal numbers. Now, since we were talking about rational numbers, so rational numbers are repeating decimals or terminating decimals, and irrational numbers are non-repeating, non-terminating decimal numbers. So pi is irrational, square root of 2 is irrational, and all real numbers involves every number that is rational, irrational, integer, fraction. So fractions are something written as a over b. Those are called fractions. So let me write down fractions. Fractions are something that is written over a over b, like 1 over 2, 3 over 6, 8 over 9. All these are the fractions. Okay, so now we can summarize everything in this picture. So n stands for the natural number. So this is a circle that contains all natural numbers, 1, 2, 3. Now if you add one extra 0, this becomes a whole number. W stands for whole number. So these are all positive integers and this is 0. If you will include all negative integers as well, this is a set of all integers. And all these integers are rational numbers. Because 2 over 1. So 2 is an integer, but if you write 2 over 1, it becomes a rational. So every integer is a rational number, but rational number also involves those type of fractions which are not divided by 1. So something like 2 over 3, right? 4 over 6, where the denominator is not 1. So if you include those 1, 2, those are rational. So Q stands for rational numbers. So, and irrational number we denote with Q prime. So Q primes are irrational numbers. And here are the examples of irrational number: pi square root of 2. And if you will combine all those rational and irrational, this is a set, this is a space of all real numbers, all reals. So this is all about a real number line. Thank you so much.